All right. Good afternoon, everyone. Welcome to my session, and thank you so much for joining. I hope you're excited for a series of serverless demos. It's going to be so much fun. So today we're going to look at building serverless APIs using Nodejs and Azure Functions. And I want you all to take a second and think about Twitter. And think about Twitter in terms of scale. So every day, in fact, every second, we are collectively creating 6,000 tweets. Twitter has 330 million users using their platform. Yearly, we're creating 200 billion tweets. That's some interesting statistics, right? Interesting numbers. Now, what if the creators of Twitter would have never created Twitter because of the amount of scale and the amount of users that they had to support? Think about that. How would our life be without Twitter? That's basically me on every single startup idea that I've ever had. I kind of thinking about scale and the fact that I have to implement and think about it and implement this application that might be used by gazillion users, I'm just giving up before even starting. But that's why I also love serverless, because it enables me to build the next Twitter without having to think of all of that. My name is Simona Cotin, and I work as a cloud developer advocate for Microsoft. I'm here with Seth Juarez and a couple other developer advocates. You can find us on this page at aka.ms avocados or on Twitter at Azure Advocates. This is a page with everyone and the areas that they tend to focus on in terms of technology. Cool. So what about serverless? Some of you here that have been in the industry for quite a while remember the time when we used to do everything on premise, and I'm sure that there's still people that are doing that. Yesterday at Serverless Days Cardiff, I actually met someone that was saying that they're running their own servers from the basement of their building in Bristol. So there are still people that go and build their own servers, buy their own hardware, and they have to answer all these questions, like how much hardware do I need? Is my hardware in a secure location? How do I architect my application? How many users will I have to support with the existing infrastructure? So that's the beginning of kind of the history of compute. And then from on-premise, we realized that actually we should be doing something about this. We shouldn't rely only on us buying our own hardware. Maybe we should outsource that. So we started outsourcing that to this model that's called infrastructure as a service, where basically someone else buys the hardware and someone else makes sure that whenever there's a hardware failure, they're going to take care of that. They're going to replace that particular server. We don't have to worry about that. It's not an investment that we have to make actively. But turns out that that's not enough. We still have to answer questions like, what kind of security threats do I expose myself to? So is there someone that can help me with that? And that's what Platform as a Service helps us with. So basically, we no longer have to maybe install and provision all those virtual machines that we would do in an infrastructure as a service type of model. But now we have Platform as a Service where the cloud provider or the company that we have outsourced that model to, they're going to make sure to provision all the VMs that I need. They're going to install the operating system for us. And more than that, they're actually going to even install the security patches for us. So we're pretty safe there. There's not a lot to manage. But still, we have to figure out how much our application needs to scale. So we have to make sure that we configure those settings. And not only that, we also pay a monthly bill. So we pay every month a certain amount of money, even though maybe our VM or our application consumes only 20% or 10% or 0% at times within that platform. So then, welcome to today, which is serverless. where we don't have to worry about any of that. The only questions that we have to ask are, how do I architect my application? And how do I make sure that my code is secure? So no more worrying about the infrastructure, no more worrying about the web server. We only focus on the code. So what is serverless? With serverless, we basically have an abstraction of servers. We still have servers somewhere, it's just that we don't have to take care of them. We don't have to configure them ourselves. We don't decide which web server is going to run our application, and we just have to deploy our code to a certain platform. We write code that it reacts to events. So for those of you who've worked with serverless before, you might be familiar with the fact that serverless code will react to events like an HTTP request, or maybe a file that has been uploaded on a storage account, or an event that has happened somewhere in the cloud. And finally, the other thing that's absolutely important about serverless is this instant scale. So the fact that depending on the number of users that are making requests to our application can be deployed in a single container, or it can be deployed to thousands of servers or thousands of containers. And we're going to pay only for the amount of compute and memory that we're using while our application is running. So that's very important. Micro-billing. For those of you who are just starting to maybe build a product and you're looking for a solution that's not going to make you pay a monthly bill, and that's not going to make you configure all the scale or all the numbers required for your application to serve a number of users, serverless is the solution for you. But then we do have this concept of functions when it comes to serverless, functions as a service. And this is where we write our code that's going to execute things and react to events. But many times we find ourselves not only having to execute code when it comes in response to an event, but we also have to execute code that kind of works in a flow. And that's what logic apps can help us with. So if you have to orchestrate multiple events, you can use logic apps for that. And on top of orchestration, logic apps also has this concept of connectors. And basically, there's thousands of or hundreds of connectors in logic apps where we can maybe use them for sending emails. Like Logic Apps integrates with SendGrid, for example, or Office 365, and we don't have to write the code that connects our application to those particular APIs. It's already done for us. And then because it's event-driven, we also have this thing called Event Grid, which allows us to orchestrate events and interact with them. But all of this sits on top of the data sources that I've mentioned earlier, and a lot of other tools like databases. We can read data and we can react to changes in our database, in our storage account. We're sure that our application is going to be monitored for security flaws. We can interact with IoT devices, and we can monitor our application. But we're all developers, right? So we definitely need to have also the development tools that enable us to build these applications. And with Azure Functions, we have IDE support, so IDEs like Visual Studio or even editor VSCode, as well as integration with Azure DevOps and monitoring application insights. And we're going to see all of these right now. So most of the session will be hands-on, and I hope you're a huge fan of demos, and I hope that the demo gods are going to be with me. So this is VS Code. How many of you, can you see it? Yeah? Perfect. How many of you are using VS Code? Fantastic. That's like 90% of the room. One of the biggest things with VS Code, so VS Code is a text editor that has been built by Eric Gamma, and one of the most powerful things about VS Code is extensions. So basically, by using those extensions, we can turn our text editor in a full IDE. And when it comes to serverless, one of the most useful extensions that you'll ever find is the Azure Functions extension. So this extension is going to help us create new projects, create new functions, run and debug those functions, as well as deploy them. I've already installed this extension, but basically it depends on Azure core tools, which will be installed whenever you go through the installation process, and you have all the steps here. So I highly recommend, if you're getting started with serverless, go ahead and install this extension. It will be the best thing that it has ever happened. Tend to be very positive. Okay, so once you have that extension installed, you're gonna be able to access it from the left-hand side on the Azure icon. So right here, you can see that I have the functions aligned there with functions, and just from here, I'm able to inspect all the functions that I have deployed in the cloud. So this extension is listing functions that I have in Azure portal, in the Azure portal. And then I can also create new projects, I can create new functions and deploy them to the cloud. So let's go ahead and create a new project. One thing that's unique about Azure is that you are able to deploy or write multiple functions within a project. So this will enable us to deploy the functions that are logically connected within the same resource. And that means that we're also going to scale those functions together. So I've selected create a new project, and then it's going to ask me what programming language do I want to use. As you can see, there's JavaScript and C#. They're generally available, and we can also use Python or Java. They're in preview mode. So I'm going to use JavaScript. And then if I go back to my file explorer, you're going to see a couple of files that have been created for us. The first one is the VSCode folder, and this is where all the magic lives. This is where our configuration for running and debugging functions is. I'm not going to go into detail. You don't have to know anything about configuring VSCode. We just know that it's there, and it's going to run for us. The next thing that has been generated is the Host of JSON file. This is where you configure settings that are available, are global to your project. Things like what kind of version of the Azure Functions runtime am I using? I'm using the second version because that's the one that is supported on all operating systems. I can also configure here things like what's the root of my, if I'm running an HTTP function, then I can configure the root of the route that my URL will have. So generally, it's going to be, by default, it's going to be API, but we can change that. We can delete API, or we can change it to, let's say, NDC. Another important file here is the local.settings.json. This is where we configure our application settings that we want to use in our local. So imagine when you're building functions or projects that you run in your local, you want to connect to your development database. When you move into the cloud, you'll probably want to connect to your production database if that's your production environment. So this is where you can configure your database connection string. And then proxies, this is a new feature, well, not really new. It's been around for probably more than a year. And this is how we can create a thin layer on top of our existing function app. Or we can actually even group multiple function apps within the same proxy, Azure Functions proxy. I don't have an example for that, but if you want to talk more about this, we can chat after this session. So then the next step, this is just the project that we've created. Next, we want to actually go ahead and create a new function. And I've used the icon there with the thunder and the plus, and that will help me create a new function and generate code for that function from predefined templates. So here, I mentioned previously that with Azure Functions and with Serverless, we react to events. So here you can see that we can create functions that react to HTTP requests or to changes in a Azure Blob storage account, or even to queue storage or service bus, and even timer trigger. So we can generate functions that will run at a certain time interval. But because we're building APIs, I'm going to create an HTTP trigger function. And then I have to give it a name. So I'm going to name it read recipes. And you're going to see why later. And the authorization level here, anonymous, it means that the URL will be accessible to everyone. Function means that the platform will generate a code for us, and unless that particular URL is being called with that code, you won't get access. So if you run it without that code, you will get a 401 saying that permission is denied. And this is all handled by the platform itself. So you don't have to do anything for that. And then admin means that only my subscription will be able to call into this function. And this can be useful when you want to guard your code you wanted to run in a certain environment. But for me, it doesn't really matter. I'm going to go with anonymous. And now we have a new folder that has been created, and that has the same name as the function that we've generated. So then function.json, this is where our function configuration is. So you see that we have an array of bindings, and we've defined two different bindings. One is an input binding, and it's the HTTP trigger. So this is how we tell the Azure runtime that we're listening for HTTP requests that are coming in. And then with the second one, we are defining the output binding, and this is how we tell the Azure Functions runtime that we are returning an HTTP response. And then our index.js file, this is a JavaScript function that will get two parameters. The first one is the context object, which will enable us to communicate with the runtime. And the second one is basically the first element in the bindings array, and it's also the request object. And you can see here that I'm using context to log information. And then I'm checking whether name exists either on the request parameters or the request body. And if it does, I'm going to return a hello something. If it doesn't, I'm going to return an error. So who's excited to have this baby running? Yeah? Woohoo! So I'm going to run this, I can either go to this debug panel, or I can even start the command palette. So Command Shift P, and then say I want to start debugging. So what this will do is, if we look at the terminal, we can see that the first thing that it will do is install extensions. So the new Azure Functions runtime is using an extension-based kind of model where we only have, in the core of the platform, we only have probably the HTTP trigger implemented. I'm not sure if even that one. And then the rest of the extensions we're going to have to install them ourselves. And the runtime will actually scan the function.json file and see what kind of bindings we're using. And based on that, it will go ahead and install those bindings. The next thing that will happen is it will run func_host_start, which starts the actual runtime. And one thing that I want you to note here, the Azure Functions runtime, it's actually open source. So whatever runs in the cloud, we can actually run in our local, we're running in our local as well. And this is what enables us to debug applications locally. And once it's started, because this is an HTTP function, it will also generate a URL that we can use in our application. So I can click on this, and it will open a browser telling me that I need to pass in a parameter. So here we can see that I've passed in name equals serverless, and it returns hello serverless. But what if we want to debug this? Well, I go back to my IDE, and I can add a breakpoint. Let's say here, if request name, maybe I have a bug and I want to debug this. So if I'm refreshing, now it will stop at the breakpoint I've just added. And then I can inspect these variables. Maybe I can change the query to be, instead of serverless, I can say No. I can say set, and then run this, and it will say, hello, Seth. So this is a primer of what you can do in your local with Azure Functions. But what we said is that we're gonna go ahead and build APIs, right? And this is just an endpoint. It doesn't do much. So I'm going to use this thing called code snippets from VSCode. How many of you are familiar with the concept of code snippets in VSCode? Awesome. There's probably half of the room. For the rest of the half, you can basically write, if you have code that you're constantly writing, having to write yourself, you can actually use code snippets to generate that code, and you're going to see how it works. So I've just typed read, and then I'm selecting read recipes, and then this will use the snippet that I've added in my config. So I can see here that I'm importing the MongoDB package. So my API endpoint will read data from a MongoDB database, and it will return a list of recipes. And the reason why I'm doing that is because I have this awesome Angular application called Tacos UI. And right now, if I go into Tacos, let me inspect element here. If I go into Tacos, you will see that I'm returning a list of tacos recipes, but in fact, this is a JSON this is a JSON file that I'm reading, so it's not very dynamic. What I want to do instead is basically go and read data from a Cosmos DB database. So Cosmos DB is a NoSQL database that supports different types of models. We can query Cosmos DB using a SQL API, a MongoDB API, a Graph API, and there's a couple more, I think Cassandra as well. But the cool thing is that Cosmos DB has an extension as well in VS Code. And right here, I can go ahead and see all the databases that I have available. I can even inspect here. And this is one document that I've created. And I can even update it right here in VS Code. So I think this is awesome. But going back into our application, what I really want to do is, instead of requesting data from a JSON file, I actually want to connect this application to a serverless endpoint. And the way I'm going to do that is I'm going to deploy this application to the cloud and then connect to that URL. OK, so first of all, we are looking at this code very quickly. We are importing a MongoDB package. And this is where, when I got started with serverless, I had to think like, OK, I know how to build applications with Nodejs. I know how to install packages in a normal Nodejs application. But how do I actually install packages in a serverless application? And turns out that the answer is quite simple. I have to run npm init-y to create a new package.json file. And I need to create it at the root folder of my project. So if you look here, I've created a new package.json file. And then the next thing that I can do is run npm install MongoDB. And this will install the MongoDB package for me and save it in the package.json file. And I'll also have access to the node modules folder. Very important here, probably this has changed in the past year, where basically I'm sharing all the node modules between all of my functions. So this is valuable information because I'm not duplicating packages. Before that, we used to have to install packages for each function that we were creating. OK, so we've learned how to install npm packages in our functions. Awesome. What's the next thing that we're doing here? We are defining an authentication object with a user and a password, and then initializing a DB object to null. And then we have this loadDB function that basically checks whether the DB object is null. If it isn't, it will just return. Otherwise, it will attempt to connect to the database that we've seen earlier, and then return that object. And once I have the DB object, I'm going to go ahead and read from the recipes collection turn that into an array, and return that as part of our response object. So this is something that you've probably seen before if you've used Nodejs or if you've ever read from a database before. One thing that I want to highlight here is the fact that we are initializing this object outside our function scope. This means that we are attempting to reuse the database connection throughout user requests. With serverless, we cannot store state. So state will always, if we want to store state somewhere, we're going to have to store it somewhere in a database or a queue or a blob storage because we don't have access to the local memory. And apart from that, the serverless provider will tell you that actually you can only run your function for 10 minutes. And after that, we can move your function to a completely different instance in a different part of the world, maybe. So you cannot rely on local state. But thinking optimistically, most of the times, that particular function will be in the same instance for probably 15 minutes or 30 minutes. So if we can gain some performance here, it's recommended that you do it. So I ran some tests here, and without reusing this database connection, I was spending probably 300 milliseconds more on each request because we would always initialize that connection. OK, awesome. So we've installed the MongoDB package, and we have all the details here to connect to a database. Let's see if that actually works. So I go ahead and run the function that we've just created. And this will start the Azure Functions runtime. And then I can click on the link there, and yay, it has connected to my database, and it returns data from that particular database. Just to make sure that I'm not cheating here, I'm going to go ahead and delete all these, nobody likes exclamation marks, right? So I've deleted these from Cosmos DB. So now if I refresh the page, we shouldn't have these anymore. Which is true. We only have one. Probably, if I refresh again, hopefully. Yeah, we left one there. Awesome. So we have connected to our database. What's the next step? Well, I have to, if some of you are super concerned about security, probably already you've raised the brow here when you saw that I'm actually displaying my database connection in my code. What if we commit this to GitHub? So what we can do now is move those connection strings to our local.settings.json file. So let's say I'm taking my password here and moving it to local.settings.json. Password. I'm saving this here, and I already know that I also have a user, and that is tacos. Okay, and I'll also need the port, which I think it's this one. So the port for connecting to our database, we can find it here. Yeah, I think it was the correct one. Oh. Okay, so I've saved all these settings here, but how do we go and access them from our application? You already know this, again. We can use process.env, and I want to take a note of this star. That means that after VS Code has run some machine learning on a lot of people using, or a lot of usage in VS Code, they've decided that env is one of the most popular fields accessed from process. So if you've updated to the latest version of VS Code, you're going to have access to this as well. So process.env.password, and then we said that we're going to replace here the user as well. Okay, user, and here, notice that I'm using a backtick, which allows me to use this interpolation notation. I'm not sure if that's the correct name. Process.env.user, and then our port, we're going to do exactly the same thing. Process.env.port. Okay, so instead of connecting hard-coding the connection strings in our code, we have moved them to this local.settings.json file. I'm going to run this again just to double-check that everything's working as expected. And from here, the next thing that we want to do is go ahead and connect our Angular application to read data from our serverless endpoint. So just testing, OK, fantastic. We're retrieving the correct data. We have access to this URL. So in order to connect our Angular application to our endpoint, I have to go and replace the URL that I have defined in my Angular service. With the URL that my serverless endpoint has generated. So this is everything I need to do to replace an existing backend with the serverless one. And now if I refresh the page on the tacos UI, bummer, I'm going to act surprised. It looks like we have CORS issues. So then the next question is, yeah, we are accessing from a different domain, so we have to set up CORS. So the next thing that we have to do is go ahead and do that in our serverless application. And to set up CORS, I can do that in local.settings.json. Right here, I have this host property, which enables me to define CORS. So this is how I would enable CORS in my local, and then in order to, we can do that in the portal as well, where we can define CORS. But let's see if this works now. So the function is running. If I refresh the page, fantastic, it's retrieved data from our database, and I can run the exact same test where I modify one of the fields in the database and then refresh the page here, but it's not as useful anymore. You've seen that it works. So then the next thing that we want to do, everything works in our local. We actually want to deploy this to the cloud, right? So that it's accessible to those million users that would want to use our application. And as I mentioned, the Azure Functions extension allows us to go ahead and deploy this application directly to the cloud. I've clicked the blue arrow there, and then I already have a function app that I've created. And I can select that so that I can deploy my code there. But as you can see here, there's a warning. It's asking me whether I really want to deploy this application. This will override existing code. As one of our colleagues and friends says, friends don't let other friends right-click deploy, right? Because this is danger zone. Even if you're working by yourself, this is going to be a problem whether you want to keep version control, you want to keep versions of your code, and you want to make sure you're not overwriting everything and it's not retrievable. So I'm going to cancel this. And I'm going to show you one neat thing that I've learned this weekend. So I've been struggling with ARM templates. How many of you have used ARM templates? Azure Resource Manager templates. Basically, infrastructure as a code. So with ARM templates, we can actually define all the resources that we are using whenever we're creating a function app, and it's repeatable and reusable deployments. I've been trying for a year to generate those ARMs for function apps, and I've been failing successfully every single time, but this weekend, it's worked. So I'm going to show you how to do that. There's another extension that can help you with this. It's called Azure Resource Manager Tools. And if you have it installed in your VS Code, the first thing that you can do is search the Azure Resource Manager template quick starts on GitHub. So there's a repository on GitHub with hundreds of templates to generate these resources. And I have to enter a search term so that it knows what kind of template I'm looking for. And I've searched for function, and I can use a template that creates a dedicated plan, which is the app service, and it's the monthly bill. We don't want that. We want the dynamic plan. So I'm selecting the dynamic one. And it's created a new folder, ARM templates, with the name of the function. And then in parameters, I can define the name, I can define a parameter for what we'll see in the next file. But let's say NDC London 5. So this string is going to be part of our URL, which is available globally, so it has to be unique. That's why I use NDC London 5. I already deployed a couple of them. So I'm saving this, and then looking at Azure deploy.json. This is where the magic happens. This is where we declare the resources that we want to deploy. And right here in VS Code, we have a JSON outline. And this is going to walk us through the main elements of a Azure deploy file. So the first thing that we have to define in a template, ARM template, is the schema. This JSON is going to be validated against the schema to tell us whether what we're about to deploy is correct or not. The next thing is the content version. This is where we version the template. So this is our version. The list of parameters. This is what we're going to use in order to make things dynamic. So imagine here we have one of the parameters is the app name. And I'm actually going to show you this with something even faster. So having that Azure deploy.json file gives you this deploy to Azure button. And when I click this, it will take me to a page where I can input those parameters. So in this case, it's a UI. Because I want to allow this to anyone that goes to my GitHub page. I want to allow them to create new applications. And you can see here that I can select the subscription, the resource group that I want to deploy this to, and the location. But then there's also app name, DB user, DB password. These are parameters that I want to define in my deployment template. Because whenever I'm redeploying this, I need to specify a different app name. Does that make sense? Yeah? Okay, cool. Another thing that I can deploy, I can configure is the storage account type. And you can see a cool thing is that I can define default values. So if nobody specifies these parameters, I can give a default value so that people don't have to enter these. And also allowed values. So that's super cool as well. The next thing that we can define here is variables. So these are things that we're going to reuse throughout our template. They're not necessarily immutable, but they're not going to change, and we're going to want to use location in multiple, for example, location in multiple parts of our template, and we don't want to execute these functions. For example, resource group.id, we can execute this function. We don't want to execute it throughout our template. And then resources, this is where the actual description of the resources that we need to deploy is defined. So you can see here that I need to, in order to deploy a function, we need a storage account where our code will live. We also need the app service plan, which is what we use for billing. An app service, which is where our code is going to be deployed. And I think that's all. So here we're defining the storage account, but I'm going to walk through this. But while we're walking through the template, we can go ahead and deploy the function that I have in my local, and I can do that with the same extension, which is the Azure Resource Tool Manager something. Deploy one of the Azure Resource Manager templates in your workspace. That's the option that I care about. And it says that I have to log in first. So Azure login, it's giving me this annoying interactive thing. I have to paste in the code, continue, and I'm now logged in. Awesome. So now if I try again, deploy, I'm selecting the current folder where I've defined the template, and then I will use an existing resource group, which is NDC London, which I've created previously. And if I go to my portal, to the list of resource groups, and search for NDC London, we're going to immediately see that I've successfully deployed 2 deployments, and then I have one that's in progress. So I'm going to click on that one, and I can monitor all the resources that are being deployed for me. We can see here that a storage account has been deployed, a server farm, that's the app service plan, and I can even see operation details, so some of the logs that are available for us here. And while that's happening, we can look at these definitions where I'm basically saying that I want to deploy Microsoft app service plan. This is Microsoft websites, and the name is going to be the function app name that we've defined earlier. The location, we're going to retrieve that from parameters. It's of type function app, and we can also define what it depends on. So this means that when we're deploying those resources, those are the ones that are going to be deployed before our site here. And we can define properties. And in fact, this is not going to work because I messed up. The template that we can generate using the extension is using the older version of functions, which is 1, and an older version of Node. So I've put in a PR this weekend to update these, but it hasn't been accepted yet. So this is where we specify those app settings. This is where we're going to add our user connection string. This is where we're going to add anything that's sensitive. So let's see if this has been deployed. Yes, it has been deployed. We're going to have to update the application settings. And the way we're doing that is I can go into the portal, and instead of using 6.5.0, I'm actually going to use 8.11.1, which is the latest Node version. And also the extension, it has to be 2 instead of 1. So see, all the app settings that we had in our ARM template there, JSON template, they're reflected in the portal here. And I didn't have to do that manually. That's why I think these ARM templates are so powerful. I love them. So I've saved this. And if I go to the overview page, I should be able to see the URL. And it tells me that the function is up and running. But actually, we have no code here, right? Because we only deployed, so that ARM template, it's only describing the infrastructure or the resources that we need so that we can deploy that code to it. So we know our function app is running. The next step is deploying our code. And I can deploy my code using the right-click deployment. But what would be even more interesting was if I had my code in a GitHub account, in a GitHub repository, and then connect a CI/CD pipeline to always push my code to this particular function app whenever I make a change. So I already have my code on GitHub. It's the repository you've seen earlier. So what I'm going to do is I'm going to go to Azure DevOps. So that's dev.azure.com. And I can configure a build pipeline right here. So in pipelines, I have this builds screen, and I can create a new build. And it's going to ask me, where do you want to deploy your code from? I want to deploy it from GitHub, and I want to use an existing connection. That's basically telling I've authorized Azure DevOps to read code from my GitHub account. And then I want to deploy this node binar repository. And my repository already has this Azure pipelines.yaml file. So you can see here that I can define my build pipeline using YAML configuration. You can also use a UI for that. I much rather have it in code, because this way it's versioned as well. So in this Azure pipelines YAML file, I define what kind of image I want to use to run my code, and then to run my build. I want to also run npm install. Remember, in our code, we depend on MongoDB. So we need to install that package. And then what I want to do is archive my code together with my packages. And this is a task that's predefined in Azure DevOps. This is the name of the task. This is the display name of the step that we're executing right now. And then the next thing that I want to do is publish that zip file to a location in my Azure DevOps environment. And I'm going to run this. And this will take me to a page, to a dashboard where I can see all these steps that get executed. And there's a couple of things that we can see on this screen. How many of you have used VSTS before? Fantastic. This is the equivalent of VSTS. It's the newer version. It's called DevOps pipelines. And there's a couple of things on this screen. So we can see, first, that's the last commit message the message for my last commit on this repository. Then you can see who made this commit. We also have a link to the actual repository where we're reading data from. We have predefined the branch that we're using and the commit number or hash. And then you can see the steps that we've defined earlier with their names. So here, npm install archive files, how long that particular step takes. We also have access to the actual logs. So here I can inspect if something goes wrong. I can actually have a look what happened or what kind of commands have been executed. So now the green tick here it means that this step has finished, whereas the blue one, it means that it's still running, it's in progress. Another cool thing that we can see is the number of seconds that we spent during this build. It's useful because if you run this build for every single commit and at some point something bad happens, it will take longer. So you have a history of how long your build takes, and you can spot anomalies there. But from here, so this is just building our project. On every single commit that I make on GitHub, it will trigger this build. But our goal is to actually deploy our code into the cloud, right? So I've clicked on release there. I hope you've seen, yeah. And from my build, I will be able to create a release as well. And this is of type app service deployment. And in order to define the properties here, I'm going to have to use a subscription. So this is my subscription, and then the type of app that I want to deploy to is a function app. And then I want to deploy, what's the name of the function app that I want to deploy to? So remember, we've created NDC London. So now I want to deploy my code to that. NDC London. Come on. And it's loading. Takes a while. 5. You said 5. Perfect. Thank you. OK, so I'm saving this. And now I want to release it. So it's using the artifact that's been created with the build. And I can go into this release and see, again, what's happening right there. So if everything here works correctly, my code will be deployed to the new function app. But if we look at the function app, already you might figure out that there's one thing that we're missing. Anyone can guess what? What's that?
Maybe the secrets?
There you go. Perfect. So set there has the secret. we are missing the secrets, right? Because we configured them in our local, but local.settings.json, where we have the details for connecting to our database, are never deployed to the cloud. They stay in our local. So now if I go into my list of functions here, I could either go to our portal, but we could also do this from VS Code as well. So if I look here, NDC London 2, if I refresh, that's my previous deployment, my previous attempt. Now we have NDC London 5. So from here, I can access the application settings that we've seen earlier. And we can see that we don't have a user defined, we don't have a password defined. I hope I won't break the release. Maybe I'll just wait for this to finish, because this is pushing my code, and if I edit application settings, I'll mess up with the, I think. But basically, what I can do is I can add a new setting, I can download remote settings, and I'm going to do that because you can see here. Do I want to override Azure Web Storage? Yes. You can see here that I have an instrumentation key for monitoring applications and the connection string to the Azure storage, and I don't have that in my local, so I want to download it. And if I look at my local.settings.json, we can see these new settings. Please. While that's happening, I'll go back to the function itself. We can see here that no code has been deployed. I think now we might have access because it's taking a while to read that code. But from here, from the overview page, I have access to application insights. And application insights, that's what we use to monitor our function. So there's this screen that I absolutely love. That's the live metrics screen. And this is gonna give me real-time information about what's happening with our function. And right now, this is a very bad screen where it says that my app is offline, and that's the case because we have just released code to it. So let me see if that finished. So we've succeeded, and I want to go back to our function, NDC. And we can see our function, our code has been deployed here. I can retrieve the URL from this particular UI, so get function URL, I can copy it here. And if I try to access it, because we don't have our secrets, it will give me an error saying that an error has occurred. And now on my application screen already, we can see that request that's coming in. So let's go ahead and now upload local settings to our cloud. And it will add our user and our password. So now if I refresh this page, it should give me data from our database. Fingers crossed. This is usually not a good sign. Or it is. So this is data coming from Cosmos DB. And we can see the live metrics here, the second request, which was successful. And I want to show you one last thing. How many of you have used the artillery? Are you familiar with artillery npm package? Artillery is used for load testing. So what I can do with artillery is now make a dozen of requests to Azure Functions and show you how we can see the requests coming in. And right now we can see that here we have one server online. But if I go ahead and I'm actually going to copy this. So you can install our artillery from npm. And this is going to start a quick test, which will run 10 requests and from 20 users at the same time. And I have to pass it in the URL itself. Let me go to my... OK, so we can see the requests coming in. The number of servers increasing. So this is scaling. And also, if someone tells you that there's no servers in serverless, you just take them to the screen, and they will see it happening. You also have access to the server name and how many requests per second are coming into a certain instance running our code. And this is the output from artillery. So I think this is everything I have. The last thing that I actually want to show you, probably you've noticed that when we have our function in the cloud, the URL says recipes. It doesn't say read recipes. The way we configure that is in our function.json file. We can define a route. So here you can see that we can configure the method that we're listening to, which is here is get, but we can also configure a route. So here we're saying that we want to override the name that we've given the function, and we want to configure it to read from recipes, to add recipes to that. Okay, so I think this is a success. This is definitely, the demo gods have helped me. What have we managed to do today? We've managed to understand what serverless is, kind of. We've managed to create a new project in our local using VSCode and the VSCode Azure Functions extension. We've also managed to create a new ARM template, infrastructure as code, and we've deployed the new function app and the function using ARM templates. We've also configured CI/CD, so using Azure DevOps, we are now pushing codes to our new function on every single change that we make to our repository. And we've also seen how we can use application insights to monitor traffic that comes into our function. And obviously, this will give us, it will give us information about whenever errors happen into our application as well. So far, everything has been successfully, lucky me. So we haven't seen that, but you can use this screen for that as well. If you're looking to learn more about Azure Functions, about Azure Functions and serverless in general and Azure pipelines, go to these links. You'll find a lot of documentation. I highly recommend you check out Microsoft Learn Serverless. Those are modules. They're basically self-paced modules where you can go in a sandbox, a cloud shell will be spun up for you, and you can execute commands there, and you can learn about serverless. You'll get points as well. And it's for free, so you don't need an Azure subscription. You can run your code there as well. And if you want stickers, I have some here, so feel free to pop in and find them. Thank you so much.